The heliopause, which is the boundary between the heliosphere, which is the bubble of the solar wind surrounding the solar system, and the interstellar medium, which is the material between the stars, appears to be rippling and creating oblique angles in an unexpected manner. This discovery was made by scientists just in time for Halloween. Hello everyone, and welcome to another video. Today we'll be looking at how NASA just detected something terrifying entering our solar system. Yeah, you heard it right. It is not a new idea that heliopause is not static, but in the past 10 years, scientists have come to the conclusion that it does change shape over time. Data from Voyager 1 and Voyager 2, the only two spacecraft to exit the heliosphere up to this point, as well as data from NASA's Interstellar Boundary Explorer IBEX satellite, which studies the emissions of energetic neutral atoms, ENAs, were used to make this discovery. ENAs are produced when solar winds and the interstellar medium interact with one another. The Voyager spacecraft provides the only direct, in situ measurement of the locations of these boundaries, but only at one point in space and time. Eric Zernstein, a space physicist at Princeton University, wrote in an email to Vice, "The Voyager spacecraft provides the only direct in situ measurement of the locations of these boundaries. IBEX contributes to the completion of those data." The data have been used by scientists to develop models that can anticipate how the heliopause shifts over time. In a nutshell, solar winds and the interstellar medium exert a pulling and pushing force on each other, which results in a border that is always shifting and shifting again. However, new research into the heliopause has uncovered data that directly contradicts the findings of the earlier studies. IBEX was able to catch the brightening of ENAs that suggested asymmetries in the heliopause over the course of several months in 2014. The researchers eventually recognized that the asymmetries did not correspond with the predictions, as observed by Vice. In addition, when the scientists looked back at the data collected by Voyager 1 and Voyager 2 during their travels, they discovered that the heliopause had undergone significant shifts in a relatively short amount of time. This helps to explain why there was such a significant time difference between the two probes' initial forays into interstellar space, which took place in 2012 and 2018 respectively. However, that sort of motion by the heliopause conflicts with the models as well. In a paper that was published on October 10th in the journal Nature Astronomy, the researchers called the discrepancies intriguing and potentially controversial. They plan to continue studying the heliopause in the hopes of gaining more insight from NASA's Interstellar Mapping and Acceleration probe, a new and improved satellite that can detect ENAs and is scheduled to launch in 2025, according to Zernstein's interview with Vice. Up until that point, all we can do is speculate on the strange occurrence that is taking place in the spooky depths of the solar system. Our solar system constitutes a relatively insignificant portion of the entire cosmos. Beyond the limit of our solar system, there is a considerably larger portion of our universe to explore. This has been demonstrated both by the depth that James Webb's initial photos have offered, as well as by the excursions that Voyager 1 and Voyager 2 have conducted into interstellar space. However, recently, researchers have seen a number of scary shifts in the heliopause, which is the boundary between our solar system and the space between the stars. The heliopause is the boundary that separates the space of our solar system from the space of the interstellar medium. It does this by the virtue of its position as the solar system's most distant point of extension. Alterations to the heliopause have always been an interesting topic of study for scientists for this reason. However, data that was just found hints to some frightening developments that our existing theories of the heliopause are unable to explain. When the data collected by NASA's Interstellar Boundary Explorer were analyzed, the researchers found evidence of the modifications IBEX. According to Space.com, the satellite was able to collect numerous brightening energetic neutral atoms, ENAs, which suggested that there was a lack of symmetry in the heliopause. In addition, as they were going through the collected data from Voyager 1 and Voyager 2, they discovered that the heliopause had been undergoing some shifts. The scientists also discovered that the changes in the heliopause that occurred between the time that Voyager 1 and Voyager 2 entered interstellar space were so significant that they challenged the present concepts that we have regarding the boundary point of our solar system. These profound shifts may also explain why there's such a big gap between the two probes as they enter the interstellar medium. Earlier this month, researchers presented their findings in the form of a study that was published in the journal Nature Astronomy. In it, they refer to the changes in the heliopause as possibly controversial. They also plan to continue researching the limit of our solar system, and they will employ NASA's Interstellar Mapping and Acceleration probe to attempt to gain a deeper comprehension of these alterations. However, until that time comes, researchers will have to rely on the spacecraft like Voyager probes and the data that we already have in order to gain a deeper understanding of interstellar space. And that's all for today's video. What are your thoughts on this? Let me know in the comments section down below. I hope that you found this video interesting, and if you want to see more videos like this, please consider subscribing to my channel. See you in the following video with some more of the latest updates, and until then, stay tuned!